Somewhere on this planet right now, there is a single farm milking more cows than the entire population of a small American town. And it is doing it almost completely without human hands ever touching the animal. We are talking about facilities that produce enough milk in one single day to fill an Olympic swimming pool, run by robots, satellites, and computer algorithms that know more about each individual cow than most farmers ever knew about their entire herd a generation ago. By the end of this video, you are going to understand exactly how a glass of milk goes from a massive industrial farm to your refrigerator. And the scale of this process is going to completely change the way you look at that carton sitting in your fridge door. If this kind of behind-the-scenes industrial breakdown is something you enjoy, smash that like button right now, subscribe so you do not miss the next one, and drop a comment letting me know which part of this process surprises you the most. Let's get into it. To understand how billions of liters of milk get produced every single year, you first have to understand the sheer scale we are talking about. The largest dairy farms on Earth, found in countries like the United States, China, Saudi Arabia, and parts of Eastern Europe, are not small family operations with a red barn and a handful of cows grazing in a field. These are industrial complexes housing anywhere from 20,000 to over 100,000 cows on a single property. Some of these mega farms are so large that they have their own zip codes, their own power plants, their own water treatment systems, and even their own veterinary hospitals on site. When you are managing that many animals, you cannot rely on old-fashioned methods. Everything has to be systemized, automated, and optimized down to the smallest detail. Because even a tiny inefficiency multiplied across 100,000 cows becomes an enormous problem very quickly. It all starts with breeding and genetics, long before a single drop of milk is ever produced. These mega farms do not just let nature take its course, they use a process called artificial insemination combined with detailed genetic selection. Scientists and farm managers analyze the genetic profile of each cow, looking for traits like high milk yield, disease resistance, and udder health. Then they select the best possible genetic matches. Some of the top dairy bulls in the world have their genetic material frozen and shipped to farms across multiple continents, meaning a single high-performing bull from Wisconsin might father thousands of calves spread across farms in 3 or 4 different countries. This is not random breeding. This is closer to a carefully engineered production line, designed from the genetic level up to maximize milk output. Once a calf is born, it is immediately separated from its mother, usually within the first 24 to 48 hours, which is one of the more controversial aspects. The calf is then moved into a separate nursery area, often housed in individual pens or small group housing, where it is bottle-fed. A milk replacer formula designed to give it the exact nutrients it needs to grow quickly and healthily. Female calves, who will eventually become the next generation of milk producers, are raised separately from male calves, who are typically sold into the beef or veal industry since they cannot produce milk themselves. This separation process, while emotionally difficult for many people to think about, is built entirely around efficiency and disease control, since young calves are extremely vulnerable to illness when housed alongside a large adult herd. Now, here is where the real scale of modern dairy farming starts to become obvious, and it is something most people watching this video have absolutely no idea about. On these mega farms, cows are not milked by a human standing there with a bucket. They are processed through massive rotary milking parlors that rotate in a continuous circle. A cow walks onto the platform, gets connected to automated milking equipment by a worker or robotic arms, or on the most advanced farms, by robotic arms using laser-guided sensors. And by the time the platform has made one full rotation, which usually takes around 10 to 12 minutes, the cow has been completely milked and simply walks off the other side. These rotary parlors can process anywhere from 60 to over 100 cows per hour, running continuously, sometimes 24 hours a day in shifts, which is the only way it becomes physically possible to milk a herd of 100,000 animals on a regular schedule. Quick pause here because I want to know something from you. Before this video, did you have any idea that milking had become this automated and this industrialized? Drop a number in the comments. 1 if you had no idea, 2 if you already knew a little about this. I am genuinely curious how many of you are learning this for the first time. And if you are finding this breakdown interesting so far, now is a perfect time to hit that subscribe button, because we still have a lot of ground to cover. The moment milk leaves the cow's body, the clock starts ticking, because raw milk is extremely perishable and bacteria begin multiplying almost immediately at room temperature. This is why every single mega dairy farm is built around an obsession with speed and refrigeration. The milking equipment is directly connected through a closed system of sterile stainless steel pipes that carry the milk straight from the cow to massive refrigerated holding tanks. Without the milk ever being exposed to open air or human hands, these bulk tanks immediately cool the milk down to around 38 degrees Fahrenheit within minutes, which is critical for slowing bacterial growth and preserving freshness. On the largest farms, these holding tanks can store tens of thousands of gallons at a time, essentially functioning as massive refrigerators the size of small buildings, constantly being filled from one end while tanker trucks drain them from the other. This brings us to one of the most overlooked parts of the entire mass production process: the logistics of getting that milk off the farm and to a processing facility before it spoils. Specialized refrigerated tanker trucks, often carrying anywhere from 5,000 to 6,000 gallons per load, arrive at these mega farms multiple times per day, sometimes every few hours. Each truck driver follows a strict route schedule because timing is everything. Milk that sits too long without proper temperature control can spoil or develop off flavors. On the largest farms in the world, tanker trucks are arriving and departing almost constantly, creating a non-stop logistics operation that never fully stops, even overnight. Once that milk arrives at a processing plant, it goes through a series of steps most people have genuinely never thought about. First comes pasteurization, a process developed back in the 1860s by the scientist Louis Pasteur, which involves rapidly heating the milk to a specific temperature, usually around 161 degrees Fahrenheit, holding it there for about 15 seconds, then rapidly cooling it back down. This process kills harmful bacteria without significantly affecting the milk's nutritional value or taste. And it is the single reason why milk became safe enough for mass distribution in the first place. Without pasteurization, the entire modern dairy industry as we know it simply could not exist at this scale. After pasteurization, most milk goes through a process called homogenization, which prevents the cream from separating and rising to the top of the container. Homogenization works by forcing the milk through extremely small nozzles under high pressure, which breaks the fat molecules down into tiny, uniform particles. This is exactly why modern milk looks and pours the exact same way every single time you open a new carton, regardless of which farm or which batch it came from. Let me pause again for a second because I have a question for you. Do you buy whole milk, 2%, or skim milk? Drop your answer in the comments. Because believe it or not, the difference between those options is not about different cows or different farms. It all comes down to how much natural fat content gets removed during processing. And remember, if you are enjoying learning about this entire industrial process, make sure you have liked this video because it genuinely helps this content reach more curious minds just like yours. Now, let's talk about something most people never consider, which is exactly how a single dairy cow can produce enough milk to feed this entire massive system. A modern dairy cow, especially breeds like the Holstein, which is the black and white cow most people picture when they think of dairy farming, can produce anywhere from 6 to 8 gallons of milk per day, which adds up to roughly 2,500 gallons per year from a single animal. To put that in perspective, that is enough milk from one single cow to fill an entire small backyard swimming pool every year. Now multiply that by 100,000 cows on a single mega farm, and you start to understand how these facilities are capable of producing literal billions of liters of milk annually. This incredible output does not happen by accident. It is the direct result of decades of selective breeding combined with precisely formulated nutrition. These cows are not simply grazing on open pasture like older generations. Instead, nutritionists design highly specific feed mixtures called total mixed rations, blending ingredients like corn silage, alfalfa hay, and soybean meal, all calculated down to the exact percentage needed. Some of the largest farms even use computer software that adjusts each cow's individual feed ration automatically based on data collected from sensors. And this brings us to one of the most fascinating parts of modern mega dairy operations: the sheer amount of technology involved in monitoring each individual animal. Many cows on these advanced farms wear electronic tracking collars, equipped with sensors that monitor everything from body temperature and activity levels to rumination time, which is essentially how much the cow is chewing her cud. This data gets transmitted in real time to a central computer system, where algorithms analyze patterns and can actually predict health problems before they become visible to the human eye, sometimes detecting early signs of illness, lameness, or even reproductive issues days before a human worker would have noticed anything wrong. Farm managers can pull up a dashboard and see real-time data on every single cow. Let's talk about water for a moment, because this is something almost nobody thinks about. A single dairy cow drinks somewhere between 30 and 50 gallons of water per day, which means a farm housing 100,000 cows needs access to several million gallons of fresh water daily just to keep the herd hydrated, not even counting the water needed for cleaning. This is exactly why the largest dairy operations in the world are typically built in regions with reliable access to massive water sources, and why water management has become a major challenge. One more thing worth mentioning before we wrap up. The waste management side of these operations is just as industrialized as the milk production itself. 100,000 cows produce an enormous amount of manure. Many megadairies use what is called an anaerobic digester, a massive sealed tank that breaks down manure and captures the methane gas it releases during decomposition. That captured methane gas is then burned to generate electricity, sometimes enough to power the entire farm itself, and even sell excess electricity back to the local power grid. The leftover solid material after this process gets used as fertilizer for the crops that grow the cattle feed, creating a closed-loop system where almost nothing goes to waste. So when you really step back and look at the complete picture, a modern mega dairy farm is not simply a farm in the traditional sense at all. It functions more like a fully integrated industrial facility. The next time you pour yourself a glass of milk or pour some into your morning coffee, take a second to think about the incredible journey behind it. All of it working together just to get that simple carton into your refrigerator. If you made it all the way to the end of this video, thank you so much for sticking with me through this entire breakdown. It genuinely means a lot. Let me know in the comments which part of this process surprised you the most, whether it was the rotary milking carousels, the genetic selection process, or the sheer scale of water usage. I read every single comment. If you learned something new today, make sure to like this video, subscribe if you have not already, and turn on notifications so you do not miss the next deep dive. I will see you in the next one.